Hello everybody. Here we go again with pointers. In this video, I just want to take a rather verbose approach to talking about pointers again at an introductory level. And I'm going to go through the same steps I did in a previous video, and I'm going to end up with a nice memory map table that we saw in the previous video as well, the Introduction to Pointers video. But the reason I want to do this is to show a lot of different types and to tell you that you can make pointers to point to any type that you have available with C. So let's just go through this, and I'm going to be cutting and pasting quite a bit of code, so I won't be doing a lot of typing here, but you can always stop and type in the code if you'd like. This is more of a demonstration than it is to introduce new things. Let's start with these variables, and these are just ordinary variables. I have some unsigned integers, I have some integer values, there's a float in here, and there's a double. So I've got quite a few variables. And what I'm going to do with this is I want to take these variables and I want to make pointers that point to the variables. Now again, the purpose of this is to go through the process of declaring pointers, initializing them, and using them. Now, let's go ahead and let's make pointers for all of those variables. So I'm just going to copy and paste the code in here. And you can see the same notation of the previous video. We have the asterisk, and Visual Studio is determined to put the asterisk there, so I'm going to stop fighting it and leave it there. So I have declared pointers to all the variables that you see up here. I've got a pointer to age, which is a type integer, and a pointer to children, which is a type integer. And it bears repeating at this point that a pointer to an integer is not the same type as an integer. So that would be a type mismatch, as I will demonstrate in the future. So I've got some regular integers here for number and value. So I'll declare pointers to those, and those are the same ones I used in the Intro to Pointers video. I've got some floats, so I'll have a pointer to energy, a pointer to mass, a pointer to velocity, again using the asterisk over here on the left. And finally, I have a type double. I've got distance and pressure, so I will make pointers to those as well. So now I've got variables up here declared and initialized to all those values that you see, and I have declared pointers to point to all those variables. So that's the way you do that. That's how you syntactically create a pointer to these various types. Now, let's initialize the pointers with the addresses of the variables up here. So we just need to use our address operator to do that. So when I put the code in here, then you can see I'm using the address operator and I'm initializing the pointers. Pointer age is going to be the address of the variable age. So same process. So when you have a pointer, in order to initialize it to an address, then this is one way you can do it. Notice that you do not put the asterisk or anything else over here on the left. It's just the variable itself. Then you use the address operator to get the age of the variable you want, and then you store that into the pointer. And the pointer does have to point to the correct type. That is, in this case, age is an unsigned integer, and we have to have a pointer to an unsigned integer, which we do here. So those do have to be consistent in the types. So I've just declared, I just initialized all of those pointers to the addresses, and here is where I declared the pointers. So now we have variables that are set to these numbers, and we have pointers that also point to all those variables. Now, using that, I'm just going to create another table here to output some of these variables, pointers, addresses, and so on, so that we can see what they look like. So again, we're kind of investigating what this information looks like if we were able to look into the memory of the computer. So I'm going to paste in some cout statements here, and we can see the results that we get. So let's start with the column headers for the table, and let's start with our first variable, which is age. So here's a cout statement. Here are the column headings. So there'll be a variable. We'll have the name of the variable. We'll have its value. We'll have its address. So this is our memory map, I'm calling it. We'll start with variable age. We'll print out the value of age. We'll print out its address. And we'll do that for all the other variables as well. So I'm just going to put the cout statements in here for all those other variables. Let's start by pasting in 3 more. So we'll do the children, the number, and the value, and we're just making a table. So we'll give the value, we'll give the address. Now, I've got a variable up here called energy, which I need to compute. So if we are just using our basic physics and we want to put in the energy in terms of the kinetic energy, for example, then I can do a calculation. So let's just use our normal variables and let's do a calculation here that we can use to calculate the energy. So I'm going to get the lines of code for that and I'm going to paste those in. So let's go ahead and drop those in here. I didn't copy. Let's try that again. So now I've got the two correct lines that I want, so I'll paste those in. And I'm going to calculate the energy and I'm going to print that out. So here is just the normal calculation that you would use, using the regular variables, not using pointers. So energy is 1/2 times the mass times the velocity squared. So 1/2 mv squared is what we have here. Now I want to output the energy variable along with its the name and its value and its address. And we'll do the other remaining variables as well. So I'll paste in the rest of the lines. And there are quite a few. Okay, so, and they're kind of long as well. So I calculated the energy. Then I'm going to print out the remaining variables that I declared up here. Lots of variables. So I had the mass, the velocity, the distance, the pressure, which is the variable name. Then underneath the value column, there's the value. Then I'll print out the actual value of the velocity and the distance and the pressure. And I still need the energy. I forgot to get the energy. I'll put that in a second. And then we have the addresses over here of all those things. But I need to go get the line that prints out the energy. So I'll now include that one. So now we have all of them. So we have these a lot of variables, 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9 different variables. So this, like I said, it's verbose. But I'm making a memory map. So this will give us the variable, it will give us the value, and it will give us the memory address of all these things. So now let's run the program and let's see what the output looks like. And notice I've not used pointers yet. And all of that, I haven't used the pointers. I'm just using the variables and I'm using the address operators to get the address of everything. So next we will use the same thing with pointers. But before we get there, let's compile and run the program to see the output here. Now we can look at the output. And here's the table. So you can see from here, we have the variables listed, children, number, value, all that. And they're just listed down the page. Then here is the energy that we calculated. It's weird that I've got children in here twice. Why is that? Well, anyway, we have the age, we have the children, we have the number, we have the value, we have the energy, the mass, velocity, distance, and pressure. And you have the values for all of them. You know, age is 22, children is 1, the duplicate of children is 1, number is 7, value is 5. We calculated the energy. See, we did the energy calculation, and then now that's output here. And on the far right, we have the actual memory addresses where each of these data items is being stored. So this is the address in memory of my computer right now where this information is stored. So this represents then a memory map, and I'll be using these a lot. So we have always the variable, the value, and the address. All right, now let's move on, and I'll take out this redundant thing here for children. And then I'll fix that, and then we'll do the same thing with using pointers coming up. So now let's do the same table, but let's use pointers. So I'll paste in these two lines, and where I have gotten, what I've listed variable up above in the table, I'm just going to change that to pointer, because I'm going to use pointers now to reference the same information that we did with the regular variables. Alrighty, so we have the pointer, we have the value, and we have the address of the pointer. And this time I'm going to print out what the pointer is pointing to. So this dereferencing operator asterisk is going to be shown here. And instead of showing what the pointer contains, I'm going to show what the pointer is pointing to. That's because I want to get the same result as I did up here using these regular variables. So where I have age up here, if I dereference the pointer to age, then I'll get the same thing. So I'll get that value, which is 22. And then if I want the age, the address of age, I use the address operator up there, but in order to do it with a pointer, I just list the pointer. The pointer contains the address for age. So I can get the same table using pointers that I produced up here just using the regular variables. So that's what I'm getting at here. So I'm going to go ahead and put in the other lines of code, and then we're going to calculate energy using pointers. So I'll paste in some more output. So here, we're just going to print out the variable pointer children dereferenced, and we'll dereference it here, so that will just give us how many children, what the value is for number, and so on, and then just the address of the number, address of value. Now, let's compute the value for energy. We used regular variables up here. How would you compute energy with the pointer notation? So let's add the line of code here to do that. So here's the calculation using pointers. Instead of using the variable energy, I can dereference the pointer to energy, and I can set the contents of that, what does that point to? So the thing, let me say it again, the thing that is pointed to by pointer energy, I can set it using an assignment statement. So I am going to use the same equation, so it's 1/2 times, so that asterisk is the multiplication star. This also has an asterisk, but that's because I'm dereferencing the pointer to mass, and that's the same thing as I got up here with mass. So this is the regular variable notation up there, and here's the pointer notation for it. Then I'll multiply that times the velocity squared, but in this case, instead of using the variable velocity, I will use the pointer to the velocity, and I'll dereference it. So I can do the same equation, the same calculation that I did with ordinary variables using the pointers. So that is what is shown in that line here. Now, if you're confused about an asterisk followed by an asterisk, then you might want to just put some parentheses around that, and I'll go ahead and do that here. So I can put parentheses there and over here, and then that really points out that this is a multiplication, whereas here that's a dereferencing of the variable pointer mass. Now, I've calculated the energy using pointer notation. Let's complete our memory map table by printing out the energy and all those other things. So here's the code to do that. So we are going to print out the energy, and I'm going to dereference it. I'm going to use the dereferencing operator to the pointer, and I'll dereference it. That'll print out the actual value. That's what the pointer points to. And then I'll print out the address of energy, which is saved in the variable pointer energy. Okay, the same thing for the mass. We'll dereference the pointer to mass to get the actual value, and we'll print out the address of mass. So I'm not printing out the addresses of the pointers. That would be different. I'm just printing out what the pointers contain. So when I finish with this, and I'll go ahead and compile it and run it, then you'll see I get the same output as we did by using the regular variables up here in this table. So we have the regular variables, and then we have the pointer equivalent. So let's compile the program and run it. Now we can look at the output, and sure enough, you'll see that the numbers do look the same. So the top table, this table up here, is the one that I created just using the regular ordinary variables. And now we have the equivalent where I'm using the pointers. So if you want to get the age using the pointer, then you dereference it. So we dereference pointer, and we get 22. We dereference the pointer to children, and we get 1, which is the same thing we get with ordinary variable children and 1. We also get the same addresses. If I want the address of age, then here's the address, and that address is the address that's stored in the pointer. Okay, so notice up here, I'm printing out what's contained in the pointer, so you do actually see the address there. So that's not the address of the pointer, it is the address of age. Now, later on, we can show the actual locations where the pointers are stored and the addresses where they're stored and what they point to, but that's not what I'm showing in this table. So we have two different ways then that we could go about printing out this memory map. We could use ordinary variables or we could use pointers. All right, now let's continue and let's add in the pointer variables to this. So now we are going to complete our memory map by putting in the variables that are pointers. Okay, so that's going to be all of these variables here. So now we're going to add those to our memory map. Continuing, I've put in a cout with a couple of inlines just to skip some space between the table above and the one we're going to make now with pointers. So now let's paste in our code to make a table that will include the pointers. So this time, let's compare them. Up above, I dereferenced the pointer. This time, I'm going to print out the information about the pointer variable itself. So we have pointer age, pointer children, and all those things. So we'll print out the variable, we'll print out what it contains, we'll print out its address. So we will have now a complete memory map which includes our pointer variables. So the address operator is used here to get the address of the pointer, and then we just reference the actual pointer variable to get the address it contains. And then this is just the name, which is a string constant here. So that will print out all of our pointers and where they are located in the memory and what they contain. So let's paste in the code for the remaining variables that are pointers. So we'll put that code here. And there are a lot, right? So we had a pointer for all of our 8 or 9 variables. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we had a lot of variables, and it is verbose. I'll admit it. I told you in the beginning it would be. But this then just completes our memory map table. So in our table, we're going to add the names of all of our pointer variables. We're going to print out what they contain, and we're going to print out their addresses. So this will tell us where the pointers themselves are stored, and it will show us what they have internally, what they contain, and the name of them. And now let's compile and run the program, and we'll have a complete table. Now we can look at the output. I had to reduce the font of the output in order to get all 3 tables to show up, but here they are. So I've talked about the top one already. So we just used ordinary variables to make that memory map. Here we did the same thing, but we used the pointer notation instead. And then at the bottom now, I've added in the variables that are pointers. So we have our pointer age, our pointer underscore children, all those variables. And on the right side, we have the locations in memory where the pointer is stored, and we have what the pointer contains. So I won't go through all of these. This is very similar to the example I did in the introduction to pointers, but let's take a look at a couple of them. So pointer to age contains 3AFD18, the hexadecimal address of the variable age, which we can see up there. So pointer age, sure enough, it points up here to where the age value is stored. And if we want to dereference it, then we use our indirect addressing technique for that. So first of all, we start at this address here. That's where the pointer is. There we find another address. We go to that address, which is up here, and we find the value we're looking for. So that's indirect addressing. It's 2 steps. How about pointer children? Well, the pointer itself, it is at this address in memory. It contains the address 3AFD0C. And if I take this address and go there, 3AFDOC, then I find the value 1. So that's indirect addressing. And indirect addressing is accomplished by using the star in front of the pointer. So now we have a complete memory map which shows all of our variables. And the first part of this first table, it's just repeated here using the same different notation, using pointer notation. So that's really a duplication. But we continue the table, either that one or if you want to take this one, same thing. We continue it by adding in our pointer variables, and now that completes the memory map. So using all these numbers on the screen, you can trace out where the pointers live, what they point to, what the pointers contain and what they point to. Now, why would you want to do all of that? Well, you probably wouldn't. Why would you want to take something simple like an ordinary variable like age and and pressure and change it into all of this complicated stuff? Well, you wouldn't. So let's close this down and let's go back to this program. So this program, once again, it's the basics of pointers. It shows you how you can declare them. It shows you how you can initialize them. And it shows you how you can use them, in a calculation. Well, not that one, but how you can use them in a calculation down here. And these tables show you the contents of memory and how pointers are stored and how they're used. And that's very complicated. There's a lot of stuff going on here. And I've made it more complicated by using a lot of different examples, but I wanted to show you different types and use different pointers. But you wouldn't write a program like this. So if you're starting to get worried about this, what advantage are these pointers giving me? Then you have a good reason to. Because it's much, much simpler just to stick with regular, ordinary variables to do your calculations. There's no reason to complete or do an equivalent version of this by using pointers. This is just an illustration of the syntax and using something that is familiar to introduce something that's new, which is pointers. Now, since you wouldn't do anything like this in reality, what might you really do? Well, let's modify the program so that we can demonstrate that. Well, let's take this in steps. Let's suppose now that we wanted to use the pointer technique in order to do a program. Now, in reality, what you would do is you would just ignore these. You don't need to have regular variables and pointers. You need to use one or the other. So let's see how we can just use pointers. And the way we can do that is we can include the new operation, which you have seen already. So when you declare something with pointers, like an unsigned integer pointer age, then you can say equals a new, and then the type, a new unsigned integer. All right? And we can do the same thing with pointer children. That's equal to a new unsigned integer. All right? So that is one thing that we can do, new unsigned int. And now we don't really need to have those variables declared up there. We have a new unsigned integer that we can create with the pointer when we declare it. So I'm going to go ahead and do the same thing for these other variables. And I'm going to just pause the video and I'll type that in and then I'll go over it so you don't have to watch me make my typing mistakes. So I've typed those in. So when I'm declaring the pointers, I have pointer to number, which is an integer. That's just a new int. Pointer to value equals a new int. So each time that I declare a pointer, then I can allocate space for it by using new. So here's a pointer to energy, which is a float, equals a new float. And so on. Pointer mass is equal to a new float. And then these things down here, the distance, then when I declare it as a pointer, I can initialize it by using new and double. Now, what this does is it tells the operating system to go create a space in memory that would store a double, or go create a space in memory that would store an unsigned integer, or go create a space in memory that would store a new integer. So that's what new does. New is a command or request, I guess, to the operating system to allocate space in memory for a particular type variable. The other thing that's missing here is if I'm going to use this, all of that stuff, then how can I set the initial values? When I declared regular variables, we just use the equal to 22 or equal to 1 or just use an equal sign to initialize it. Can you do that here with this technique? Let's try it. Okay, let's suppose I have pointer age is a new unsigned int, and let's set that equal to 22. Now, you can tell already, and then with Visual Studio, you get this red underscore indicating that there's a error, that it cannot do that. And one reason for that is, well, here's an equal sign. Okay, I've declared unsigned integer, which is a pointer to age, and I've made it a new unsigned integer. Now I want to set it to 22. So I can't use an equal here, and I can't combined with one there. I can't use two equal signs like that. So to initialize it, there is a way that you can do it but you want to use parentheses instead. So I can put the initial value 22 in parentheses, and that works just fine. So now, instead of using these variables up here, I can use nothing but pointers. I don't have to have these other variables up there. All right, so I'm just going to go ahead and I'm going to initialize these other things. So bear with me. So let's say that's children is 1. And let's, I'm just going to go type those in, and then we'll come back and take a look at them. So I'll pause the video for a few minutes. So now I'll put in the initial values for all those things. So now we have a unsigned integer, pointer age, is a new unsigned integer initialized to 22. Okay, here's a double, pointer to distance. That's a new double, and we'll initialize it to 1,000. So that takes the place of this up here. Now that I've done this, then I don't need those variables anymore. I'm using strictly the pointer notation in order to declare and initialize my variables. So I can delete that altogether. Just remove it. I don't need those variables anymore. Since I have used the new operation here, then whenever you use new, the operating system gives you the address, and that address is stored in the pointer. So the operating system returns the address, we save it in the pointer here, so there's no need to try to reset those pointers with those variables. And in fact, you can't, because I've just deleted the variables. So they're not, the age, children, and number, they're not there anymore. So I don't need this either. I have deleted the variables, so I can't print them out anymore. So I need to just take away this part of my memory map table, because I don't have the variables there anymore to use. So that's why you see the red lines. So I don't need that anymore. So I can take that away. So now I'm strictly using pointers everywhere. Okay, so I can delete a bunch of stuff. And now, everywhere that I'm accessing and outputting information, I'm using the pointer notation. So I'm going to use the dereferencing operator to get the values for these things, and I'm going to have their addresses, which are contained now in the pointers. So I don't need the variables anymore. Now, when I get down here, I'm just finishing off the table with the remainder of the variables, which are pointers. So I don't really need this either. Alrighty, I do need to calculate the energy, but I don't really have the variables anymore, so I don't need to pretend that I do. So I can just print out the bottom part of this table, which just prints my pointers, and that gives me all the information that I need. So let's go ahead and compile the program, and let's do that. I've left the part of the table that uses the dereferencing operators in here. So this will help us see the values. So if we want to see the values, then we still need to see this. So let's bring in the output. So now we'll look at the table. And here we have used the pointers only. I don't have the variables listed anymore. They're gone. So we have a pointer to age. We have its value, the value. And I should say we've dereferenced pointer age. We get the value. And that's the address where the value 22 is stored. Now, pointer age down here is stored at that location in memory. It contains the address here, 0BDAFA8, and that happens to be the address where 22 was stored up here. But in this case, we didn't use the variables. We just declared the pointers, and we used the new command, and that caused the operating system to allocate a space in memory, and it stored the value 22 there. So now when we're looking at this output table, we're looking at the address the operating system gave us. So the operating system, it gave us this value. That value was stored in the pointer for age, and the location, that address location was initialized to 22 because we used the 22 up here. So this shows you then that you have a choice. You can use the pointer notation strictly without using any variables, or you could use the much longer method that we did earlier in this video, which was just a method to show you and compare regular variables to pointers and maybe get across the syntax. You may not be convinced yet. You might still think that Well, that's a lot more trouble than using ordinary variables, and I'm still going to agree with you that that is more complicated than using regular variables. But this does point out new. It does show you the syntax that you can use to initialize a variable when you dynamically create it. This is a dynamically created variable. It's not an array, but it's just a regular variable. But the real advantage of pointers comes into play when you're doing data structures. I will admit that it's much easier to do a program like this if you want to calculate the energy and you want to make a table of all your variables. It's much easier to use regular variables with the address operator. I'll admit that. But pointers are extremely valuable when you get to data structures, and that will be something we're building up to. So you cannot do a linked list without a pointer. You cannot do a tree structure without a pointer. You cannot really implement a graph without pointers. So we're working our way toward the real value of using pointers, but we're using some simple techniques to get us there so that you can see the syntax and you can hopefully understand what's going on in memory as we do the things that I've been showing you. So I'm going to stop this program, this video. The program is part of it. I'll stop that too. But I'm going to stop the video here, and then we will continue to look at other features of pointers in upcoming videos in this series. So goodbye for now.